Let us understand a very simple concept called as intercept. Now what is intercept? Let's understand. We have a line L and we have another line M. These two lines are intersected by a transversal X, right? Now why it is a transversal? Because this line is intersecting line L and line M at distinct points A and B. Now these distinct points A and B, when we join them, we get a segment, and this segment is called as an intercept. So intercept means it's a segment joining the points of intersection on the transversal. So we can say that this segment AB is an intercept formed on the transversal on line X by lines L and M, right? So very simple. So we know what is an intercept. Intercept is a segment formed by joining the points of intersection on a transversal, right? Now let's understand a very important property, and the name of the property is property of three parallel lines and their transversals. Let's understand this. Every property has a statement, so this property also has a statement. Let's understand the statement. It says that the ratio of the intercepts made on a transversal by three parallel lines is equal to the ratio of the corresponding intercepts made on any other transversal by the same parallel lines. Now, I know the statement is too big. You're confused by listening. Don't worry, it's very simple. Let's understand this. It says that the ratio of the intercepts made on a transversal by three parallel lines. So the very first thing is we require three parallel lines. So let's have a line L, line M and line N, and we are saying that all the three lines are parallel. These three lines are intersected by a transversal. So let's have one transversal first. So we have a transversal here, X. So since it is a transversal, it is going to intersect L, M and N at distinct points, and we are taking those points as P, Q and R. It says that these three parallel lines are intersected by one more transversal on any other transversal. We take the other transversal as Y and their points of intersection as E, F and G. Now understand one thing before we get into this statement. Now, if I ask you, on this transversal, which are the intercepts formed by lines L, M and N? How many? How many intercepts? We will say, yes, we have an intercept PQ. We have another intercept QR. Do we have one more? Yes, we have one more, that is PR. Remember that. Then, we have an intercept here, EF, then another intercept FG, and we have another intercept that is EG. Remember that, right? Is that clear? One more thing before we learn the property, right? If I say here I consider PQ, so what is going to be its corresponding intercept here on this line Y? It is going to be EF. Same way for QR, its corresponding intercept is going to be FG. And for same way for PR, its corresponding intercept is EG. And these are the concepts you got clear. Now we'll understand the statement better. So what we have is we have three parallel lines and two transversal. What the statement says is the ratio of the intercepts made on a transversal, ratio of the intercepts made on a transversal by three parallel lines. So we take the ratio. Now if I consider this intercepts, one is PQ, the other one is QR. So what is the ratio of that? The ratio of that is going to be PQ upon QR. So the statement says that this ratio is equal. It is equal to what? It is equal to a ratio. Ratio of what? Ratio of the corresponding intercepts made on any other transversal by the same parallel line. Now tell me, for PQ, what is its corresponding intercept? You know that already. What is that? EF. Very good. For QR, what is its corresponding intercept? It is FG. That means when I'm saying taking the ratios PQ upon QR, this ratio as per the statement is equal to which one? It is equal to EF upon FG. That is what the property says. So property says a very simple thing. Whenever there are three parallel lines intersected by a two transversal we have, then we know that the ratio of the intercepts formed on one transversal is equal to the ratio of the corresponding intercepts formed on any other transversal. That means we should have three parallel lines and two transversal minimum. When we have that, we get the ratio of the intercepts to be equal. Only thing is take the ratios properly. Whatever ratios we have taken here, we need to take its corresponding intercepts ratio there, right? But as you said, there are different possibilities of the intercepts here. So is this only one possibility? No, we can have another possibility. Suppose I say I take the ratio of PQ and PR. So if I take PQ upon PR, tell me it will be equal to what? It will be equal to, yes, very correct. It is EF upon EG. So that is another possibility we get. So we can PQ upon PR is equal to EF upon EG. Isn't that easy? Very simple, right? Beautiful. So you understood this. Now, can we have one more here? One more possibility? Yes, we can have. If we take this now, we take PR and QR. So if we take QR and PR, what is it corresponding there? It is nothing but FG and EG, isn't it? So what is the ratio we write? We write QR upon PR is equal to FG upon EG, isn't it? Wasn't that easy? This is what the property says. So remember, when are we going to use this property? Whenever we have 3 parallel lines at least and 2 transversals. And we know that when we have that, we'll get the ratios to be equal. But remember, the way to present it is, first we should write the lines are parallel. Line L parallel to line M parallel to line N. Then we should write the name of the 2 transversals. We should write on transversals X and Y. And then we write the ratios equal. So then we can write, if we write this ratio equal, again write the reason into bracket. Property of 3 parallel lines and their transversals. Any one of this we can use in the sum as per our requirement. Isn't that easy? A very important concept.